पुट माय वीडियो, मेरा मैं देख रहा हूँ. Yeah. So today we are going to learn about modulation. Modulation क्या है? सबसे पहली चीज, write down the definition of modulation. Modulation is superimposing of X thing on Y thing. Now wait. Superimposing what on what? पहली बात, superimposing क्या है? आकाश को लेके जाता हूँ टैटू आर्टिस्ट के पास, उसके ऊपर मैं टैटू छपवा देता हूँ. आकाश बदला. Did Akash change? Did his body change? Did his personality change? No, it did not. उसके ऊपर कोई चीज छप गई है. Something has been superimposed. Did the original Akash change? It did not change. Akash is Akash. He has not lost his originality. He's just carrying some information. We superimpose ink on paper. We call it a newspaper. Similarly, I can superimpose information on a wave. I can superimpose information on a wave. बोला था ना, रेडियो टेलीफोनी होती है, रेडियो नेविगेशन होती है. रेडियो वेव्स की मदद से नेविगेशन कब होगी? जब उसमें इंफॉर्मेशन डाली जाएगी. जब उसमें इंफॉर्मेशन डाली जाएगी. एंड इसी इंफॉर्मेशन को रेडियो वेव के ऊपर सुपर इम्पोज करने की प्रोसेस को हम लोग कहते हैं मॉड्यूलेशन. परफेक्ट. Shriram, I want you to listen to the briefings that I'm saying, because these things will come in handy when you explain it to the WPC examiner. Okay, the way I'm teaching it to you. So what is modulation? Modulation is the process. It is a process of superimposing information on a radio wave. On a wave, superimposing information on a radio wave. If you come across definitions, it is one of the few things. Okay, information ही नहीं, intelligence, superimposing intelligence, superimposing information and superimposing audio wave. तीन चीजें superimposing. 1 intelligence, 2 information, 3 audio frequency and audio wave. Write down audio frequency, AF, audio frequency. Superimposing this on कौन सी चीजों के ऊपर आप superimpose कर सकते हो? A carrier wave और number 2 a radio frequency. ये तीनों चीजें सेम है और ये दोनों चीजें यहां पर जो बताई सेम है. ऑडियो फ्रीक्वेंसी क्या है? हमारी आवाज. ऑडियो फ्रीक्वेंसी क्या है? हमारी आवाज. इट्स अ वॉइस. ऑडियो फ्रीक्वेंसी इज आवर वॉइस. एंड व्हाट डू वी हैव इन आवर वॉइस? इंफॉर्मेशन, इंटेलिजेंस. आई एम स्पीकिंग टू यू. व्हाट इज दैट? दैट इज इंफॉर्मेशन, इंटेलिजेंस बीइंग ट्रांसफर्ड फ्रॉम वन प्लेस टू अनदर प्लेस, राइट? It is being transmitted audio. So it is an audio frequency. The voice that is coming out of my mouth, it is going into my laptop's microphone and it is going inside the circuit. The voice signal is going inside my laptop's circuit. When anything exists in a circuit, it's called a frequency. When anything exists outside in the atmosphere, like a wave, it exists as a wave. मैं आवाज निकाल रहा हूँ हर्ष, मैं आवाज निकाल रहा हूँ, ये पार्टिकल्स वाइब्रेट कर रहे हैं. इट इज अ साउंड वेव. इट इज गोइंग टू माय माइक्रोफोन. माइक्रोफोन इज कैचिंग दोज वेव्स एंड कन्वर्टिंग इट इनटू इलेक्ट्रिकल सिग्नल्स. अब वो सेम साउंड मेरे सर्किट के अंदर है. उसे हम लोग क्या बोलेंगे? बाहर थी तो तब तक ऑडियो वेव, अंदर आ गई तो ऑडियो फ्रीक्वेंसी, है ना? सर्किट के अंदर है. खुशी, मेरे को लग रहा है आपको समझ में नहीं आ रहा.
सर मुझे आप दिख नहीं रहे हो.
मैं दिख नहीं रहा हूँ? पिन किया है मेरे को?
हाँ सर करा है. आपका सिर्फ प्रोफाइल दिख रहा है मुझे.
तो डीपी रीजॉइन करो फटाफट. समझ आया? एनीवन एनी डाउट्स येट? हर्ष समझ आया नहीं आया?
The word after superimposing is information or intelligence or audio frequency on a radio.
This or this or this.
Okay.
On this or this.
On a radio or?
carrier wave. Radio frequency or carrier wave. Radio frequency or carrier wave.
Okay.
ओके खुशी लिख रहा हूं मैं.
सर आप पॉज हो, दिख तो रहे बट एक जगह स्टिक हो गए हो.
अभी
नहीं सर.
इंटरनेट
तो फिर
चेंज
से.
करके देख ले मैं
हाँ.
क्या बोलूं. ठीक है. एनी डाउट्स एज ऑफ यट. सो जैसे मैंने आपको बोला, वेट फॉर 5 4 3 2 1. कैन यू हियर मी खुशी?
यस सर.
तो व्हाट इज मॉड्यूलेशन? सुपर इम्पोजिंग इंफॉर्मेशन, इंटेलिजेंस और ऑडियो फ्रीक्वेंसी. ये क्या है? इंफॉर्मेशन है. इसको मैं कहाँ सुपर इम्पोज कर रहा हूँ? एक कैरियर वेव पे या फिर एक रेडियो फ्रीक्वेंसी पे. अब अगेन कैरियर वेव एंड रेडियो फ्रीक्वेंसी इज द सेम थिंग. Carrier wave and radio frequency is the same thing. How same thing? If it is existing in the circuit, it is called a radio frequency. इसी रेडियो फ्रीक्वेंसी को मैं अगर एंटीना के अंदर घुसा दूंगा, इसी रेडियो फ्रीक्वेंसी को अगर मैं एंटीना के अंदर घुसा दूंगा तो एंटीना से बाहर निकलेगा. इट विल गेट आउट ऑफ द एंटीना. Once it is out of the antenna, it exists as a wave called a radio carrier wave. Called a carrier wave. If it is inside the circuit, it will exist as a radio frequency. Okay. खुशी डाउट्स म्यूट कर ले. So now let's say Ankit is my friend. Let's say Ankit is my friend. I and Harsh is my friend. They both are friends with each other also. Harsh, Ankit, where do you stay? You stay in Bombay, right? Harsh stays in let's say Bengal. Now I'm taking a masterclass on modulation. If you can join in now, please join in. So now let's say Harsh wants to go to Ankit's place. Harsh does not have, he wants to pass a message to Ankit, let's say. Okay. Harsh wants to pass a message to Ankit. वो बंगाल में बैठा हुआ है, बोलेगा अंकित मेरी बात सुन. उसको सुनाई देगा? घंटा सुनाई देगा? नहीं सुनाई देगा ना. क्यों? उसकी आवाज में उतना दम है कि वो बॉम्बे तक चला जाए? नहीं है. एटीसी पायलट के साथ कम्युनिकेट करना चाहता है. दे बोथ कैन सी ईच अदर. ओह ही इज फ्लाइंग ओवर देयर. एटीसी को उसको मैसेज बोलना, भाई थोड़ा डाउनविंड एक्सटेंड कर ले, ऊपर चले जा, नीचे चले जा, लेफ्ट राइट ले ले. वो चिल्ला के बोलेगा, उसको सुनाई देगा? नहीं देगा. My audio wave, my audio frequency does not carry that much amount of energy for it to go from here to there. If Harsh was to come to Ankit's place, would he be able to come to Ankit's place walking by himself? No, he needs a mode of transport. What does he need? He needs a mode of transport. He needs a carrier. Similarly, a radio and information cannot be transmitted just like that. It needs a carrier. It needs a mode of transport. Okay? It needs a mode of transport. Now Harsh wants to send some information to Ankit. Harsh wants to send some information to Ankit, or let's say Harsh is the information and he wants to come to Ankit. Can he walk and go? No, he cannot. He needs to take a mode of transport. Let's say he takes a train. Train is the carrier over here. Harsh sits inside the train. The train takes him to Bombay. Harsh gets outside the train. The process of Harsh sitting inside the train, information being superimposed on the carrier, is modulation. What comes after modulation? The carrier wave goes from A to place B. The carrier wave goes from place A to place B. This is called propagation. This is called propagation. अब ट्रेन है, सरफेस के अराउंड चलेगी, surface waves. This propagation can also happen like sky waves. This propagation can also happen like space waves, anything. समझ आया? पहले मॉड्यूलेशन हुई, फिर प्रोपगेशन हुई, अब आएंगे ये प्रोपगेशन हुई रिसीविंग एंटीना. रिसीविंग एंटीना वहां के स्टेशन है, रेलवे स्टेशन. So the train arrives there. Right? And Harsh finally gets out of the train. The process of Harsh getting outside the train is called demodulation. Extracting information out from the carrier wave. Okay? Ujjwal, the reason I wanted you to join is this is a part of RTL also. And I'm taking a masterclass on modulation.
Got it.
Okay, this is also being recorded. The portion that you have missed, please check it out in the video that I'll be sending.
Yeah, sure.
Works?
Yeah.
Basically, I'm teaching modulation. Modulation is the process of superimposing information. Guys, जो भी मैंने आपको सिखाया, write it down in your own concepts. I'll just give him a brief overview. Okay, modulation क्या है? It is superimposing information on a carrier wave. Let's say you go and have a tattoo. Did you change? No. You just got information imposed on you. That is superimposing of information. Let's say Harsh. Let's say if the ATC is there, ATC is saying something. Will the pilot be able to hear it? No. He shouts. No. You need a carrier. My audio does not have enough energy to go and reach the pilot, right? I need a carrier. Similarly, my audio wave needs a carrier wave. My audio needs a carrier, a mode of transport. So let's say Harsh to meet Ankit. Harsh is from Bengal, Ankit is from Bombay. Harsh is the information. He sits in the train, he catches a train, takes the train, comes to Ankit, gets off the train, gives him information. The process of Ankit sitting inside the carrier, the train, is called modulation. The process of the train actually going to Bombay is called propagation. And Harsh coming outside the train is demodulation, extracting information out from the carrier. Works? Janvi video on कर. So now that being said and done, we have done modulation. Modulation is of the following five types. Modulation is of the following five types. Please make notes. Amplitude modulation, frequency modulation, phase modulation, pulse modulation, and keying. And keying. Write it down again. Amplitude modulation, pulse modulation, frequency modulation, okay. Ankit, just increase my screen ka size. Ujjwal, Janvi, please turn videos on.
आपकी स्क्रीन ना प्रेजेंट नहीं हो रही है.
Can everyone see my screen?
Yes sir. हाँ तो मेरी नेटवर्क इशू हो रहा है. Of course 2 मिनट तो.
जी. See me? 5 phone as well. Today's modulation. Okay. Information, intelligence, or audio wave on radio frequency. Yeah. Works. Write down the following 5 types of modulation. Okay. Just follow my screen. Okay. Okay, I'm gonna write it down. Just follow the writing. There's gonna be some cleaning happening, but keep following my screen. So now that you have written down the 5 different types of modulation, the first one that we are going to study is keying. You guys can see me. Can you guys see my screen? Okay, great. So what is keying? What is keying? Now, this is one of the prehistoric dinosaur times ka thing. Okay, this is one of the prehistoric dinosaur time का type of sending information. How did we send information back then? अभी हमारे पास कोई audio signal है नहीं. This type of thing had been used for telegraphy. This was used for telegraphy. What do you see over here? You see over here a carrier wave. आप यहाँ पर क्या चीज देख रहे हो? आप यहाँ पर देख रहे हो carrier wave. अब मैंने इस चीज को क्या किया है? श्री राम. ओके, अब हम लोगों ने इस चीज को क्या है? ठीक है, इस कैरियर वेव को हम लोगों ने ब्रेक कर दिया. इस कैरियर वेव को हम लोगों ने ब्रेक कर दिया. वी गेव इट ब्रेक्स. वी डिड कीइंग. कीइंग में क्या ऐसे? किसी ने देखी रोमियो एजेंट वॉल्टर मूवी एक आई थी, एजेंट वॉल्टर, और फॉलो पैगी कार्टर, द कार्टर फिल्म्स ऑफ मार्वल. मार्वल कोई फॉलो करता है? नहीं. उज्जवल, एनीथिंग? ठीक है. सो नाउ बेसिकली क्या होता है, अगर लेट्स से आपके पास एक रेडियो अपैरेटस है जिसमें आप फैट 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 यू कैन ट्रांसमिट, यू कैन होल्ड द सिग्नल का ट्रांसमिशन. एंटीना एक है, हमने उस पर करंट डाली. यस, मॉर्स कोड. You can control the transmission. Okay, you can send it in bursts of energy, in short bursts of energy. मैंने क्या किया? मैंने इसके अंदर ब्रेक्स डाल डाल के मैंने इसको की किया. क्या किया? की किया. आई एम टेकिंग माई पीटीटी. पीटीटी एक चीज होती है जिससे मैं ट्रांसमिट कर सकता हूँ. ठीक है, आई टेक माई पीटीटी एंड आई डू डॉट डॉट डैश डॉट डैश डॉट 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 dash 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 dot dot dot. So what I can do over here is I can end up sending this kind of a transmission. 1 2 3 dash 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 again dot dot dot. So let's say this is an antenna, and this part is the inside of the antenna, and it is being propagated outwards. Okay, in this direction it is being propagated outwards. So what is happening, have a look. When I'm doing that, the things that are coming out of the antenna, they are coming out like this: beep, 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 beep. This is called an interrupted carrier wave. What is it called? I am interrupting the carrier. I am interrupted the carrier. ओके, क्या कर दिया मैंने, उसके अंदर ब्रेक्स डाल दिए. ठीक है, आई कैन प्रेस द पीटीटी लाइक डॉट 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 डैश 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 डॉट डॉट डॉट, है ना. कैन आई सेंड दिस ट्रांसमिशन. एक एंटीना है, एक एंटीना है, और उसमें मैंने एक वायर के थ्रू ऑडियो फ्रीक्वेंसी, ये कैरियर वेव डाल दिया. अब मेरे पास यहाँ पे क्या है, मेरे पास यहाँ पे एक स्विच है. अगर मैंने स्विच को दबा दिया तो सर्किट कंप्लीट हो जाएगा, ये ट्रांसमिट करते रहेगा. और अगर मैं हटा दूंगा तो ये सर्किट ब्रेक हो जाएगा. इट्स लाइक अ स्विच, इट्स लाइक अ स्विच. सो कैन आई प्रेस द स्विच इन अ पैटर्न so as to send Morse code? Can I send the switch pat 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 ऐसे करके to send the Morse code? Yes or no? Who all agree? Give me a hand up. Hands up. समझ आ गया? No doubts? So now tell me something. Is there any separate information that I am putting inside this wave? No. Is there anything that I am superimposing? No. I am just cutting the same carrier wave and I am putting them in bits and pieces. That is it. I did not give him any extra information. मैंने कुछ उसके ऊपर सुपर इम्पोज नहीं किया. I did not apply anything on Akash. Instead, I cut Akash into different pieces and I sent it to him somewhere. Bad example, I know. Getting it? So instead of writing something on a piece of paper, I cut the paper into bits and pieces, and then I'm like, okay, you arrange this paper and Morse code, you listen to this. So मैंने उसके ऊपर कुछ सुपर इम्पोज नहीं किया, तो essentially ये मॉड्यूलेशन नहीं है. दिस इज नॉट मॉड्यूलेशन, बट इंफॉर्मेशन तो है. डिड आई सुपर इम्पोज एन ऑडियो फ्रीक्वेंसी? नो. इसके ऊपर कोई एक और वेव आई नहीं, आई ना, सिर्फ इंफॉर्मेशन आया. Information in Morse code. Do you guys recognize this Morse code? Ujjwal, you should recognize what Morse code is this. What Morse code is this? What is this?
Okay, so yes.
Okay.
Dot, dash.
Whenever anyone is in an emergency, if you have an access to a radio, use the radio. Tuck, 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 tuck. Or if you are in an aircraft, you hear someone's transmission in this particular Morse code, they are in distress, they are in urgency. It's a survival thing. Okay. Cool. So see, with the help of proper coding, with the help of a proper Morse code, I can transmit information. Even if I just press this in a particular pattern, if a person who has studied Morse code, they can very well establish my location. Okay. Any doubts? But is there any extra wave that was superimposed on this? No, it was not superimposed. It's just information. Is there any modulating wave? Though there is no modulating wave. The reason why I'm repeating this, because you will be learning these very same words when I teach you emission designators. When I teach you emission designators. No modulating signal or wave. We are simply taking the carrier wave and we are cutting it into bits and pieces and giving it off. Works. For any other type of modulation, guys, For any other type of modulation, you will have an extra modulating signal. That modulating signal will 99% of the time be your voice. Okay, with the help of your microphone we will convert your voice into an audio frequency which is existing inside circuits. Is voice a digital data or is it an analog data? Is voice a digital data or is it an analog data? What is digital? Who all had computer science? Give me a hands up. Okay. अंकित, सीएस नहीं था तेरा? आईटी था ना? डिजिटल और एनालॉग के बीच में तो पता होगा? नहीं पता है? Okay. Digital is anything that has ones and zeros. Digital is anything that exists in either an off state or an on state. Okay, anything. So basically, if I have a current, so digital is anything that goes like this. So this is 1 1 0 0 1 0. Correction, 1 1 1. Anything like this is digital data. Anything up or zero. Period. Khatam. This is digital data. Cool. But what kind of, so is my voice like nah, no, it's not like that. My voice is an analog information. I can speak sare gama, kuch bhi. It's a wave. It's an analog signal. My voice cannot exist as one and zeros, right? It's an analog information. My voice is an analog information. Therefore, it has to be an audio wave. And this wave will have a frequency. I am talking to you in a high frequency voice. I am also talking to you in a low frequency voice. समझ आई डिफरेंस? जो भी है, मेरी आवाज माइक्रोफोन में जा रही है, चाहे वो कोई भी वेव हो, कोई भी फ्रीक्वेंसी. इट इज अ सिग्नल दैट इज गोइंग इनटू माय माइक्रोफोन. इट इज गोइंग इनटू द लैपटॉप्स सर्किट. What is happening in the laptop? My voice is being superimposed on the Wi-Fi waves. The video that you're seeing, that is also being superimposed on the Wi-Fi waves. It is going to my router. It is being modulated and it is going to the router. From my router, it is going to the internet, going to your IP addresses, to your laptops and devices. Over there you have a demodulator. It is extracting out my voice. It is extracting out my video and it is displaying it to you on your screens. And voice through the speaker and going in your ears. Right? This is everywhere. And it's happening right now in real life. And when you press your PTT, it is happening then also when you're speaking to the ATC. So now, there are 4 different types of modulation. Primarily, we will be asked questions on these two, even for the RTR purpose and the radio navigation purpose. Okay, amplitude and frequency modulation, these are the main 2 things. Phase modulation is not required, neither it is applied anywhere. Pulse modulation will be required in radars. That too, pulse position modulation. Okay, so now let's study amplitude modulation. Whenever we are studying modulation, we have a carrier wave जिसके ऊपर मॉड्यूलेशन होगी, जिसके ऊपर इंफॉर्मेशन आएगी. Then we also have a modulating wave जो इंफॉर्मेशन छपेगी, the information that will be superimposed. Works? So now amplitude modulation. What is the literal meaning of these words? Modulate means to change. Mod lagana. What are we changing? We are changing the amplitude. We are changing the amplitude. Frequency modulation. What are we modulating? The frequency. Works? Simple. But now we can change these a lot of things based on something. What is our change based on? Our change is based on the amplitude of the modulating wave. Whatever the modulating wave, which is my voice in this case, my voice, मेरी वॉइस की एम्पलीट्यूड को देखकर you are changing something. Okay, we'll come to that. So what is amplitude modulation? Notice I am changing amplitude of carrier wave based on amplitude of modulating wave. Okay, I am writing short forms. Please write bigger forms. Okay, Sriram, you need to write. Ujwal, Janvi, you need to see and understand how am I supposed to present it to the WPC and DGC examiner. Okay, now let me explain it to you with the help of an example. So I am going to draw a carrier wave. A carrier wave generally has a very high frequency, right? Now a carrier wave generally has a really high frequency. Arey yaar, sorry, give me 1 second. Just let me draw this. Okay, great. Take this copy. So let's say this is a carrier wave. No doubts with this. This is a carrier wave. And for the purpose of this explanation, due to bad drawing, consider the frequency is constant. Okay, this is a constant frequency. Okay, this is of a constant frequency. Perfect. Now it looks of a constant frequency. Now I have an audio wave also. This is a carrier wave. I also have a modulating wave. Now this modulating wave will look like this. Works? For the sake, this in real life is not so simple. This is like this, like an audio, an analog signal. But for the sake of simplicity and for the purpose of explanation, I'm drawing it as a simple sine curve. As a simple sine curve. Great. Now have a look. I am going to look at I am going to look at whenever I'm modulating something. Let's say I'm undergoing amplitude modulation. What am I going to do? I am going to look at the amplitude of this wave and I'm going to change iska amplitude according to that. इसका एम्पलीट्यूड देख के इसका एम्पलीट्यूड चेंज करूंगा मैं. देखते हैं कैसे. So I want to take this entire thing, copy it, paste it over here, and notice what's gonna happen. Cool. So notice this, the amplitude is constant. The amplitude is constant, right? It's going up, down at a constant amplitude. The amplitude is changing. No, it's not changing. Agreed? Now I'm going to change this amplitude based on what? Okay, now I see the amplitude here is 0. The amplitude here is at its positive maxima. Harsh, don't write right now, okay? If you miss this, you will not understand it. Modulating wave की amplitude यहाँ पर 0 है. यहाँ पे पॉजिटिव मैक्सिमा पे, वापस यहाँ पर जीरो हो गई, फिर यहाँ पर वापस नेगेटिव मैक्सिमा पे आ गई, फिर वापस जीरो हो गई, एंड देन वापस इट इज एट इट्स पॉजिटिव मैक्सिमा. Okay, so now the circuitry inside will change the amplitude of this wave like this. Here it is zero, the amplitude is going to be average. See, this is going to be the resultant wave. Notice what has happened, guys. Important. Here amplitude was zero or neutral. So the amplitude remained neutral. The amplitude remained neutral. Okay, see, amplitude is neutral over here. तो इसका हम लोगों ने क्या किया, काम करो, इसको लो, इधर रखो, इसको लो, इधर डालो. Yeah. Look how this waveform is changed into this waveform. Here the amplitude is zero. So here we made the amplitude, we kept it neutral. Here the amplitude is positive maxima. The amplitude, it is over here. Now we have increased the amplitude from neutral to increased it over here. Okay, the amplitude should be this much. The amplitude should have been this much. I've increased it to here. I've increased it to, one second guys. Have some patience. So यहाँ पर we have a positive maximum amplitude. We increased its amplitude till over here. As you can see, the amplitude of this wave is a very, very big amplitude. Again, we have the neutral point. What did we do? We took the carrier wave and we kept its amplitude neutral. Then here the amplitude is at its negative minima. Here we have kept the amplitude of the carrier wave a minimum. Again, the amplitude over here is neutral. We have kept the amplitude neutral. Again, here the amplitude is maxima. So we have increased the amplitude. What did we do? We changed the amplitude of this wave according to this wave. What does the result look like? It looks like here. Again, I'll explain. जहां जहां पर इसका amplitude ज़्यादा है वहां वहां पर इसका amplitude ज़्यादा है. जहां जहां पर इसका amplitude कम है वहां वहां पर इसका amplitude कम है. सिंपल. एंड सिर्फ ऊपर वाला साइड नहीं, इधर भी देखो ज्यादा है, इधर भी देखो कम है. एम्पलीट्यूड गोज बोथ वेज. नो, एम्पलीट्यूड गोज बोथ वेज. वर्क्स. व्हाट डिड यू नॉट अंडरस्टैंड?
The 270 position. Can you scroll a little up?
Yeah, absolutely.
The modulating wave at 270 position. How did that?
Which is
end?
at this position, right?
Yeah.
Yes. So the amplitude, this is the normal amplitude. This is the least. Is it a negative amplitude? Is it in the negative direction? Yes, it's along the negative axis, right? So the amplitude should have been an average of this and this, like the wave should have been going like this. But we decreased the amplitude of the carrier wave to only this much. What did you not tell me?
Can you say again?
Absolutely. What are we doing, buddy? We are changing the amplitude of what? Carrier wave. Right? This is the carrier wave. Did it amplitude? Did its amplitude, did it get changed? What is amplitude? The amount it goes up and down, the maximum distance it goes up and down, correct? At any given instant. Is its amplitude changing? Yes. We are changing it according to what? Amplitude of modulating wave. So basically, जहाँ पर भी amplitude, wherever the modulating wave amplitude is good, carrier wave amplitude is also maximum. Wherever, I'll say again, wherever the modulating waves amplitude is at its maximum, carrier wave amplitude we also made it maximum. Wherever the modulating wave amplitude is minimum, I made the carrier wave amplitude minimum. I changed the amplitude of the carrier wave according to the amplitude of the modulating wave. Wherever the amplitude is maximum, we kept the amplitude of carrier wave maximum. Wherever the amplitude of the modulating wave minimum, we kept the amplitude minimum. But did I change the iska frequency? Frequency remained constant. I did not hamper the frequency. I did not hamper the frequency of the module of the carrier wave. Okay, understood? Pakka. If there's any doubt, still tell me.
I
जहाँ
was
पर
wondering, I was
हाँ
wondering at 270 position is like on the negative side, right? But we are keeping it in the lower side of the.
yeah, it's negative amplitude. That's right. It's in the
Okay.
lower direction. Okay. Otherwise, how will you differentiate between a positive amplitude and a negative amplitude? Right? If this is going this, if on the upper side, the resultant is a very nice amplitude. On the lower side, also the resultant is a positive amplitude. How will you understand the difference between an A and an So now, when this kind of a wave is received by the receiving antenna, does this actually carry the information? No. Is this the modulating wave? Modulating wave was the information, right? The modulating wave was the information. Is this carrying the information? No, 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 no. It is carrying an image of the information. The information is superimposed. The information is superimposed. It's not the actual information. If someone wants to send me information, he'll draw a tattoo on Akash's body, SOS. Akash will come to me. I will read it out of the Akash's body, SOS. This is not information. It is an image of the information. That is why it is called superimpose. So if this wave, if this kind of a wave if this kind of a wave is being received by my antenna, हमको समझ आ जाएगा ओके something like that, something like that. The original information looked like this. The original information looked like this, but I am able to understand this by changing the waveform of the carrier wave. I can look at the changed waveform of the carrier wave and I can understand the original information. I think I've gone enough depth. You don't require this much depth in modulation. You do not require this for the purpose of your radio navigation exam. I'm also doing this so that you can understand your concept and for the RTR guys as well. Because they have to explain this to the examiner in front of them. Okay? आपको क्या जानना है? Changing the amplitude of the carrier wave according to the amplitude of the modulating wave. That is it for the purpose of radio navigation. Works. 1 to 2 minute break. Take a 2 minute break. Grab some water. हर्ष पानी पी लियो उसके बाद और टफ वाला पार्ट आएगा Yep, nice. So, resuming on, let's talk about. There's something about more about amplitude modulation that I want to teach you, but we are gonna leave a little bit space for that. I'm gonna teach you about sides bands and amplitude modulation, but I'm not gonna come over it very soon. I'm gonna teach you the other forms of modulation. Then I'm gonna come back to side bands. Okay. Now, once you have done one form of modulation, now the other forms of modulation become very easy. Ankit, confirm the video recording is on and continuing. आप क्या करते हो? Do you like snap it and then merge it and send it to me? Or yeah, break is a part of the video? It is a part of the video. So let's talk. It's continuing, no? Yeah, great. So now let's talk about frequency modulation. Let's talk about frequency modulation. Take this line. Now, who's gonna tell me? Harsh, what is the meaning of modulation?
Process of superimposing.
Very good. What is modulation? It is the process of superimposing. And modulation is also meaning to change. To mod something to means to change something. Okay, there are two meanings. So now, if in amplitude modulation, what were you changing? You were changing the amplitude. In frequency modulation, what will you change? You will change the frequency. It's very simple. You are changing what? Instead of this definition, the entire thing will change. Just remove this amplitude and change it to frequency. Change it to frequency. Shriram, now what did you do? You changed the frequency of the carrier wave. You changed the frequency of the carrier wave. But what did you change? What was the change based on? The change was based on the amplitude of the modulating wave. It will always be based on amplitude of modulating wave. You will look at amplitude, you will change the frequency. Now you're going to be thinking, how is that possible? It's very simple. Wherever the amplitude is at its positive maxima, frequency will increase. Wherever the amplitude is low, frequency will be low. Simple. Any doubts? Works? I want you guys to draw this diagram. So look at this. This is keying. Amplitude modulation is changing the amplitude according to the amplitude of the audio frequency or the carrier frequency, basically modulating wave. Okay, we have done this. What about frequency modulation? Please have a look. Here we have a normal carrier frequency. We have a normal carrier frequency, right? A carrier wave works. And we also have an audio frequency and audio wave, which is also called the modulating wave, which is carrying information just like a normal sine wave. Look what is happening. At a certain place, at this place, these lines are very, very close to each other. These lines over here, they're very, very close to each other. Is the screen stuck? Yes, the screen is stuck. Yes. Can you see my screen?
Yes, sir.
So in this area, if you see, यहाँ पर क्या है? यहाँ पे these all these things are very very close to each other. That means the frequency is very very high. Now over here, all of these waves, they are very very far apart. So that means the frequency is less. Again, they are very very close to each other. That means frequency is very very high. Agreed? Everyone understands this? Look what is happening, guys. जहां जहां पर इसकी एम्पलीट्यूड ज्यादा है, वहां पर इसकी फ्रीक्वेंसी ज्यादा है. Wherever the amplitude is higher, the frequency is higher. Here the amplitude is low, the frequency we made it low. Here again the amplitude goes high, the frequency goes high. The amplitude is low, the frequency goes low. And it's not one like हाँ फट करके बढ़ा दिया, फट करके कम कर दिया, फट करके बढ़ा दिया, फट करके कम कर दिया. Frequency is increasing, frequency is decreasing, 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 increasing, 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 decreasing, 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 decreasing. Getting it? It's a wave. You are changing the frequency of the carrier wave, of the carrier wave, looking at the amplitude of it, of the modulating wave, and the resultant waveform looks like this. Understand? Any doubts? Tell me. No doubts? This is what amplitude modulation looks like. Check your groups. This is what frequency modulation looks like. Check your groups. The one which does not have a name in the below part has is frequency modulation. Okay. Understand? Any doubts? Wait, Ujjwal, I'm sending it to you. Where is your chat? Okay. Any doubts? Now, as a result, now we are going to come to sidebands. Okay. What did we do? We changed the frequency according to the amplitude of the modulating wave. We always change everything according to the amplitude of modulating wave. Anything we change it according to the amplitude of the modulating wave. Okay. Phase modulation, we are going to change what? Everyone unmute and speak. Phase modulation, we are going to change what?
Phase.
The phase. Unmute everyone. We are going to change the phase. Harsh, हम लोग कुछ भी चेंज करेंगे, क्या चीज को देख के चेंज करेंगे? एम्पलीट्यूड ऑफ मॉड्यूलेटिंग वेव को देख के चेंज करेंगे. In phase modulation, what are we going to change? The phase of the, make a note, write it down, write it down.
मैं फिर
Phase
से एक्सप्लेन करूँ?
modulation. हाँ भाई,
एक बार फिर से एक्सप्लेन करता हूँ।
मैं कह रहा हूँ क्या चीज एक्सप्लेन करनी फिर से?
फ्रीक्वेंसी मॉड्यूलेशन।
फ्रीक्वेंसी मॉड्यूलेशन में आप क्या चेंज कर रहे हो हर्ष?
फ्रीक्वेंसी।
क्या देख के चेंज कर रहे हो?
क्या देख के मतलब?
एम्पलीट्यूड ऑफ, क्या देख के चेंज कर रहे हो? आपने लिखा है वो जो मैंने बोला? व्हाट आर यू आर चेंजिंग इज समथिंग बेस्ड ऑन समथिंग।
बेस्ड ऑन एम्पलीट्यूड।
एम्पलीट्यूड ऑफ व्हाट? किसका एम्पलीट्यूड?
वहीं से तो नहीं लिखा ना, वहीं से तो मैं छोड़ दिया।
अरे एम्पलीट्यूड मॉड्यूलेशन देख ले, एम्पलीट्यूड मॉड्यूलेशन देख ले, उसमें क्या लिखा है? एम्पलीट्यूड मॉड्यूलेशन क्या लिखा हुआ है? लैपटॉप यूज कर रहा है, मोबाइल यूज कर रहा है?
लैपटॉप।
हाँ,
लैपटॉप।
ये लैपटॉप है तेरा पक्का?
हाँ हाँ।
तो आप क्या कर रहे हो एम्पलीट्यूड मॉड्यूलेशन में हर्ष?
हाँ।
एम्पलीट्यूड मॉड्यूलेशन का स्टेटमेंट हो गया।
Change of amplitude of carrier wave based on the amplitude modulation of
एम्पलीट्यूड ऑफ मॉड्यूलेटिंग वेव है ना, सेम चीज यहाँ पर है। आप क्या कर रहे हो? आप फ्रीक्वेंसी ऑफ कैरियर वेव को चेंज कर रहे हो। किसको देख के चेंज कर रहे हो? बेस्ड ऑन व्हाट? सेम थिंग, एम्पलीट्यूड को देख के आप फ्रीक्वेंसी चेंज कर रहे हो। एम्पलीट्यूड ऑफ मॉड्यूलेटिंग वेव को देख के आप फ्रीक्वेंसी चेंज कर रहे हो। देखो इधर क्या हो रहा है, यहाँ पे तेरी एम्पलीट्यूड मॉड्यूलेटिंग वेव की एम्पलीट्यूड हाई है, यहाँ पे तेरे मॉड्यूलेटिंग वेव की एम्पलीट्यूड हाई है, यहाँ पे तेरी मॉड्यूलेटिंग वेव की एम्पलीट्यूड लो है, यहाँ पे तेरे मॉड्यूलेटिंग वेव की एम्पलीट्यूड हाई है, यहाँ पे तेरे मॉड्यूलेटिंग वेव की एम्पलीट्यूड लो है। ठीक है, अब देख यहाँ पर ये सारी चीजें दे आर क्लोज टुगेदर, द वेव्स, ये लाइंस दे आर हियर क्लोज टुगेदर, वेरी वेरी क्लोज टुगेदर है ना। यहाँ पे बहुत स्प्राइड अपार्ट है कि नहीं? तो हर्ष यहाँ पर तेरी फ्रीक्वेंसी ज्यादा है, फ्रीक्वेंसी ज्यादा मतलब मोर क्लोज टुगेदर। यहाँ पे तेरी फ्रीक्वेंसी कम है मतलब वेरी वेरी फार अपार्ट, करेक्ट? तो फ्रीक्वेंसी चेंज हो रही है, हो रही है, ठीक है। तो यहाँ पर देख ये नॉर्मल है, यहाँ पर तो फ्रीक्वेंसी कांस्टेंट है। हम लोगों ने क्या किया, यहाँ पर एम्पलीट्यूड ज्यादा है, यहाँ पे फ्रीक्वेंसी ज्यादा कर दो, यहाँ पर एम्पलीट्यूड कम है, यहाँ पे फ्रीक्वेंसी कम कर दो। एम्पलीट्यूड को देख के क्या चेंज कर रहे हैं? फ्रीक्वेंसी चेंज कर रहे हैं, समझा? ये फ्रीक्वेंसी मॉड्यूलेशन है। तो इसी तरह फेज मॉड्यूलेशन के अगर बारे में मैं बात करूं, व्हाट आर वी डूइंग? वी आर चेंजिंग द फेज। व्हाट आर वी डूइंग? राइट डाउन इन फेज मॉड्यूलेशन प्लीज। Phase modulation, we are changing the phase of the carrier wave. We are changing the phase of the carrier wave according to the amplitude of the modulating wave. Akash, right? Let's clear.
according to the
सेम थिंग भाई, अकॉर्डिंग टू वाला जो पार्ट है ना वो सेम रहेगा हर जगह, सेम चीज को देख के तुम चेंजेस करते हो, समझा? हमेशा एक ही चीज को देख के अगर हम लोग अलग अलग चीजें चेंज करते हैं, बिकॉज एक एनालॉग वेव में हर्ष क्या होता है, एम्पलीट्यूड ही हमारा सब कुछ है, एम्पलीट्यूड में ही हमारा इंफॉर्मेशन है। जहां एम्पलीट्यूड ज्यादा मतलब वहां आवाज ज्यादा, है ना, ये चीज। नाउ व्हाट अबाउट पल्स मॉड्यूलेशन? वी आर चेंजिंग द पल्स कैरेक्टरिस्टिक बेस्ड ऑन द एम्पलीट्यूड। We are changing the pulse characteristics based on the amplitude. Pulse characteristics of the carrier wave based on the amplitude of the same modulating wave. Check your group. फेज मॉड्यूलेशन तो समझ में नहीं आएगा, मैं बताऊंगा खुद से। पल्स मॉड्यूलेशन देख लो। मिला सबको, इमेज मिला उज्जवल? ये क्या है? अब आपको वहां पे पैम, पीपीएम, पीएफएम, पीडब्ल्यूएम ये सब दिख रहा होगा, राइट? नाउ लेट मी एक्सप्लेन इट टू यू। So now here you have the modulating wave. What are you doing? Wherever the amplitude is higher, so I'll tell you the full form first. PAM stands for pulse amplitude modulation. You are changing, but pulse ka amplitude you are changing. Here you are changing the pulse ka width, pulse width modulation. Here you are changing pulse position, and this is pulse code. Okay. Pulse code modulation is the type of modulation that is used in secondary radars. Okay, Ujjwal, and ADSB transmissions. Pulse code modulation is used. जानवी ये तो आपको मालूम है, pulse code modulation 1 2 3 4. So ये देखो यहाँ पर pulse amplitude modulation, amplitude बढ़ रही है. See, wherever the modulating signal's amplitude is higher, we are increasing the amplitude of the pulse. We are increasing the amplitude of the pulse. Wherever the amplitude of the carrier modulating wave is low, we are decreasing the amplitude of the pulse. Any doubts? No. Okay. Now we can also change pulse ka width. Here the amplitude is higher, so the pulse is very, very wide. Here the amplitude is very less, so pulse width is very less. Yes, Akash?
और स्पेसिंग का कुछ फर्क पड़ता है उसमें?
नहीं, पढ़ना नहीं चाहिए, because spacing, there is something known as a pulse recurrence rate, it remains the same. तो नहीं, स्पेसिंग का फर्क नहीं पड़ता है. दिस डायग्राम इज नॉट टू स्केल बडी. यहाँ पे थोड़ा स्पेसिंग का फर्क पड़ रहा है, बट दिस डायग्राम इज नॉट टू स्केल. आई कैन अश्योर यू दैट द स्पेसिंग बिटवीन पल्सेस विल नॉट बी अफेक्टेड. Spacing between pulses will be affected in pulse position modulation. They are very, very widely spaced apart because the amplitude is very, very high. They are very closely spaced apart because the amplitude is very, very low. Okay. हर्ष मेरी जान, बारिश यहाँ पर भी हो रही है क्या? Then we have pulse code modulation. We'll not go into the depth of this. I'll teach you when we will do radars, secondary surveillance radars. Okay. अभी जब बताऊंगा तो माथे के ऊपर से जाएगा. ठीक है. And talking about phase modulation, basically let's say if you want to send a signal, तो ये phase में पता है क्या होता है? आप एक preset code हो जाता है. If you want to send the zero data as a 0, you send the phase like this. If let's say you want to send the data as 1, you send the opposite phase, 180 degrees. So let's say if I want to send the data as 0 1 1 1 0 1, the wave will look like 0 1 1 1 and then again 0. अरे यार रुक जा. 1 1 yeah. So see, this is a 0. Have a look. I'll do it again. Huh? A 0 degrees phase. Now I want to send a 1. 1 will be 180 degrees phase. Again a 1. Again a 1. Now you want to send 0. So this. Then again a 1. So this is how it is transmitted. We don't have to actually go into the depth of this. It will not be used anywhere except VUR. Okay. But that is simply a phase comparison. We don't even call it phase modulation. It is simply phase comparison. Okay, this is not required for the purpose of your examination. You are basically understand changing the phase according to the data. That is it, period.
Sir, can you repeat?
भाई इंपॉर्टेंट नहीं है मेरी जान, छोड़ दे, दिमाग खपा के फायदा नहीं है. क्या कर रहा है? फेस चेंज कर रहा है. किसको देख के कर रहा है? एम्पलीट्यूड को देख के कर रहा है. खत्म. ठीक है. Talking about pulse modulation, I want you guys to understand that pulse modulation over here, यहाँ पर pulses ऐसे लिखे हुए थे. The pulses, they were drawn like this, correct? You need to realize that in real life, pulses or radio waves, they don't look like this. This is just a representation. This is just a representation. If I'm telling you these are pulses, no, they look like this. This thing, for the purpose of diagrams, it can be represented like this. Okay, real life में वो ऐसी होती है. रियल लाइफ में वो ऐसी होती है. ऐसी निकल सकती है वेव. एंटीना से ऐसी वेव निकल सकती है? नहीं ना. एंटीना से तो ऐसी वेव निकलेगी. अब इसमें अगर तुमने पल्स एम्पलीट्यूड मॉड्यूलेशन किया तो तुमने एम्पलीट्यूड बढ़ा दिया तो पल्स विल लुक लाइक दिस. उसकी एम्पलीट्यूड बढ़ जाएगी. Its amplitude will increase if you do pulse amplitude modulation. If you do pulse width modulation, its width will increase. Understanding? That thing was just a representation. This is how an actual pulse is. Pulse is what? A burst of energy. Okay, radio wave भेजी मैंने. Agreed? Any doubts? Saturate हो गए हो तो बता दो. I'll end the class. If not, if you can go for more 20 minutes, I'll teach you sidebands. अब तो घर पे है यार खुशी. ये दोनों बोल रही है. अब मैं खाने के लिए तो छोड़ नहीं रहा. कौन कौन सैचुरेट हुआ? Hands. You have a class at 3. This guy was telling us we will do.
Yeah, the thing is actually I'm straining myself while looking at laptop. So it's not any hard copies, right? So it's all digital. So that is what is like.
Did you get it printed?
Yeah, I got my charts printed. I didn't print the notes.
You went 4 or 5 kilometers. You got the charts printed. You did not get that printed.
No, that day the color printer was only available. It's all weird. So I thought I would get it printed some other day.
Okay.
I actually plan to spiral them and keep it like a book or something so that it has all the 4 things of the navigation thing together.
From the next batch onwards, or we are also planning to send hard copy books, but that is a down the line thing. A lot of editing and all has to be required for that. बता दो कौन कौन सैचुरेट हो चुका है. नहीं तो मैं तो कंटिन्यू करने वाला हूँ. पढ़ना है नहीं पढ़ना है खुशी है. 2 मिनट का ब्रेक ले लेते हैं. We'll meet at 45. I'll trouble you for more 15 minutes and then we'll call it a day. Then I'll send you questions for modulation. See you in 2 minutes. Videos on everyone here. ये मस्त मूड हो गया ये अभी। नहीं
नहीं सर।
इतने में फटीक किन किन का फटीक किक इन कर रहा है? किन किन का फटीक किक इन कर रहा है? शुरू करें? Let's start. So now, whenever you modulate or whenever you mix two frequencies, in the result, you get not only the original frequency. So let's say मैंने एक frequency डाली, so remember I told you leave a little space. This is what you want to do. In modulation, whenever you mix these two frequencies, in modulation, whenever you mix these two frequencies, let's say there is a frequency A, there is a frequency B, and whenever I mix these two frequencies, I modulate them. I will not, you guys will think, okay, A is the carrier wave, B is the frequency with the information or the modulating wave. You guys will think, sir, I will get to only A frequency जिसके अंदर B superimposed होगा, है ना? In which the B is somewhere, an image of B is imposed on it, maybe by changing the frequency, maybe by changing the amplitude. Now this comes under amplitude modulation. But this is not so the case. As a result of mixing, there is some distortion which happens. You not only get one only frequency, you get a range, you get a band. You get in the output a band. आपको लग रहा होगा okay, if I put 100 megahertz over here, तो मेरे को आउटपुट में 100 megahertz मिलेगा नहीं. You will get 100 megahertz नहीं, आपको एक range of frequencies मिलेंगी. You'll get a band of frequencies. You get all frequencies between 1.00, let's say 2 and 99 decimal 998 megahertz. ठीक है? This is a range of frequencies. This is a range of frequencies. This is a band of frequencies. Remember when we were doing alternating current circuits in our class 12, we had this kind of a diagram, the power curve, right? In our class 12th, when we were doing physics, we had this kind of a diagram. So this frequency in the middle was the resonant frequency. But in any given circuits, there are inductances, there are capacitances. You do not have that one perfect frequency only going into the circuit. It's not one unicolor massive. It cannot be that sharp. Everything has a range. A knife is not one single line. A knife blade is not one single line. If you look at it on a microscopic level, it is very blunt. Right? Similarly, this also has a range. This also has a width. The resultant wave will have a width. And they were like, okay, frequencies from so and so point, from this point to this point. This is the power axis. This is the frequency axis. So this is the resonant frequency, let's say 100 megahertz. all the frequencies which are above this minimum level of threshold, which are above this minimum level of threshold, which is basically like 75% par, 75% par. ठीक है, इतना आपको डेप्थ में जाने की जरूरत नहीं है. You do not have to go in this much depth. Okay, what I'll tell you to write, just write that. So we saw that, okay, from this place, from this frequency to this frequency, yeah, we can use this is acceptable. Now you'll be thinking this is a very wide range. No, no, very, very small range. Lallu sa ekdam. And what is this called? This thing is called the band, this frequency band ka width. Your internet also has a bandwidth. Any given channel, a radio frequency channel, also has a bandwidth. Only though, so the next resonant frequency can only come thoda dur jaakar, after some far away, because the bandwidth has a width. I cannot simply say, okay, you guys can take 100 megahertz frequency and the very next frequency, then you take this, then you take this frequency, then you take this frequency. No, 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 no. We cannot just use any frequency. We cannot just use any frequency. If अगर कोई बंदा है जिसके पास रेडियो है जिसने ट्यून कर दिया फ्रीक्वेंसी 100.002, वो एसेंशियली 100 वाला ही बैंड है, क्योंकि उसकी विड्थ है, वो उसके अंदर आ गया. अगर तुमको एक सेपरेट फ्रीक्वेंसी चाहिए, एक सेपरेट चैनल चाहिए, वो उस बैंडविड्थ के दूर जाके ही आएगा. तो बैंडविड्थ जितनी चौड़ी होगी उतने दूर दूर आपके चैनल्स होंगे. द वाइडर योर बैंडविड्थ इज, the more far away your channels are. Everyone agrees on this? Everyone agrees on this? ये भाई ये देखिए चौड़ा होगा तब तो जाके दूसरी फ्रीक्वेंसी इतनी दूर रहेगी ना. अगर ये बैंडविड्थ कम होगी तो ये फ्रीक्वेंसी को मैं थोड़ा पास ला सकता हूँ, खुशी है ना. सीधी सी बात है. इफ आई एम यूजिंग अ फ्रीक्वेंसी एंड इट हैज दिस मच अमाउंट ऑफ विड्थ, एनी फ्रीक्वेंसी between this frequencies, between this band is now useless. It is a part of the same frequency. उसके बाहर ही मेरे को देखना पड़ेगा, राइट. अगली फ्रीक्वेंसी उसके बाहर ही आ सकती है. You do not have to write this. ये बस मैं I am connecting your concepts to class 12th physics. That is it. कहीं नहीं आएगा एग्जाम में, जो आएगा वही है. So whenever you have two frequencies A and B and you put it through a modulator, you not only get the frequency A as an output, but you also get all the frequencies from A to A plus B, and you also get all the frequencies to A minus B. तो यहाँ पे जो ये वाला बैंड होता है, A से A plus B तक का जो बैंड है, the band which is from A to A plus B over here, this band is called the upper side band, and all the frequencies from A to A minus B is called the lower side band. And what is A called? What is A called? A तो भाई आपका प्यारा प्यारा कैरियर वेव था ना. So the similarly in this power wala circuit, in this power wala diagram, you had the resonant frequency, you had the upper side band, and you also had the lower side band. Okay, so you have the carrier frequency, you have the lower side band, you have the upper side band. Works, and it is a range of frequencies. So I'll explain it to you with the help of an example. अब मान लो आपने एक मॉड्यूलेटर के अंदर मान लो, now you have a modulator, you have a voice. Khushi, do you have a voice? Do you have a voice?
So,
No.
yes, sir.
Yes. So what is the frequency range of that voice? Do you know? It can be anywhere from 100 hertz to 5 kilohertz. This is the speaking frequency range. Singers might have a even broader one. What is the hearing range? 20 hertz to 20 kilohertz. This is the frequencies in which the human can hear audio. So any audio wave can be between this frequency. Normal human speaking frequency range is near about 2 kilohertz. Okay, so let's say now I have a microphone and that is giving me an audio frequency, let's say of 2 kilohertz. I have a carrier wave. I have a carrier wave. Inside the equipment, it is called a radio frequency. Inside the equipment, it is called a radio frequency. Let's say it is 110, 111 decimal 100 megahertz. ठीक है, कोई दिक्कत कुछ भी, मैं आई कैन टेक एनी नंबर. जो VHF RT होती है ना, VHF RT, VHF मतलब RT मतलब क्या, जिससे VHF कॉम्स, VHF कॉम्स की फ्रीक्वेंसी बैंड क्या थी, बताओ अनुष्का. अंकित,
So, from
हाँ बताओ.
30
क्या, लाउडर बाबा.
so from 30 to 300.
VHF comms, the sixth class which you said that you attended उस दिन, HF comms, VHF comms लिखवाया था.
Yes, sir.
फ्रीक्वेंसी में रेंज लिखाई थी VHF comms की.
Yes, sir.
क्या है?
So 118.02 126.
तो वो क्या है? VHF कम्युनिकेशन क्या है? अब देख, VHF तो एक बड़ा हो गया ना. VHF is a very big term. From 30 to 300. VHF can be used in many places. VHF can be used in VOR. It is a navigation aid. VHF can be used in ILS. It is a navigation aid. VHF can be used to communicate. Navigation aid. VHF can be used in radar. Navigation aid. From 30 to 300, many places it can be applied. So the international bodies, they have designated, okay, from 118 to 136, we can use these frequencies for communication purposes. Just like you have 93.5 Red FM. That is also VHF. 30 to 300, right? 93 is inside that. That is also VHF. But those frequencies, they are designated for entertainment broadcast, FM broadcast, sound broadcast. 93.5 Red FM, 94.7. So 93.5 के बाद क्या आता है? 94.7 आता है. इतना दूर क्यों आता है? बैंडविड्थ की वजह से आता है, चैनल स्पेसिंग की वजह से आता है. समझे? सो नाउ ये मैंने दो वेव डाल दी. ठीक है, ये वाली जो फ्रीक्वेंसी है, कौन सी फ्रीक्वेंसी है? VHF कॉम्स की फ्रीक्वेंसी हो गई है. यस, एवरीवन अग्रीज. VHF कॉम्स की फ्रीक्वेंसी. वेरी गुड. नाउ आई पुट इट इनसाइड अ मॉड्यूलेटर. दिस मॉड्यूलेटर this modulator is gonna give you the original frequency A, which is your RF, which is your RF. He's gonna give you 120.100, but he's also gonna give you all the frequencies up to +2. So 120.102, and he's going to give you all frequencies up to 120.9er, no correction, 0.9er 8. ठीक है, तो क्या हुआ, आरएफ आपकी ऑडियो फ्रीक्वेंसी कितनी थी, 2 किलोहर्ट्ज थी ना, तो ये वाली बिट्स कितनी हो गई, ये वाली हो गई 2 किलोहर्ट्ज। अपर साइड बैंड की बिट्स कितनी है, व्हाट इज द विड्थ ऑफ द अपर साइड बैंड, 2 किलोहर्ट्ज। व्हाट इज द विड्थ of the lower side band, this is also 2 kilohertz. So what is the total bandwidth, 2 times of audio frequency, 4 kilohertz. Understand? Understand? Now Khushi, let's say, what does your Papa Ji do? What does Papa Ji do?
I can't hear you. Say again.
You can't hear me?
Yes, actually, I got disconnected. That's why.
So you do not understand any of this?
तो वो लास्ट वाला जो भी आपने जस्ट बोला,
ठीक है, तो अब देख यहाँ पे तेरा 2 किलोहर्ट्ज का अपर साइड बैंड का विड्थ हुआ,
यस सर,
लोअर साइड बैंड का विड्थ तेरा 2 किलोहर्ट्ज हुआ, तो पूरी टोटल की विड्थ कितनी हो गई, 2 टाइम्स ऑफ ऑडियो फ्रीक्वेंसी। आपके पापा जी क्या करते हैं,
कंपनी,
सॉरी,
he is in transported company.
perfect, he is in a transport company, perfect. Let's say the father is given, Janvi, same example, huh? What is she, she is a, बताइए, Janvi will teach, you want to teach?
आप करो.
So let's say your father is in the transport business, okay, and now one fine day, because of your father's good reach in the transport and experience in the transport business, government decided to give your father a contract of Nitin Gadkari. He decided to give your father a contract for making a highway. Okay. And what is the main aim when you make a highway? You want to expedite the flow of traffic. And you want to accommodate a lot of traffic. Okay, now I'm going to teach you what is bandwidth. What is bandwidth? So your father got money, and Gadkari sahab, he gave us, okay, he gave you land this much, and all their engineers, they planned, okay, now this is 60 meters or 60 feet of land width. The width is 60 feet. This is the width that is allotted to me by the government of India. Okay, now I want to drive trucks on this. Now I want to drive trucks on this. So now they did suggested, why not I make this as 15 feet, 15 feet, 15 feet, and 15 feet. So I make 4 channels. I draw lines. I draw lines. Okay, I have one road. It's a one-way road, let's say. And मैंने बीच में lines draw कर दी. So at one given point of time, how many trucks, how many lanes can I have? 4 lanes. See, how much is the width of each lane? How much is the width of each lane? See, this total thing is 60. I cannot go more than this because then the farmers will protest. Okay. So this is only 15 feet. The width is 15 feet. But do I need 15 feet to drive a truck? No, no. I don't need 15 feet to drive a truck. The width was more. We had only 4 number of channels. Gadkari Sahib is like, this is too much width. Do we need this much width? We don't need this much width. Exactly. So you cut down on the width. What do? आप थोड़ा width में cut down कर देते हो. आपने बोला यार एक काम करो इसकी width आधी कर दो. And what were you able to do? Because you reduced the width to half, 7.5 feet. You had more number of lanes available. Yes. So now instead of having 4 trucks, you can have 8 trucks. If I reduce the width by half, I can increase the number of lanes by 2. If I am able to reduce the bandwidth, I can increase the number of channels by same. Similarly, government has given allocation, okay, from 118 to 137. 136.975, rounded off to 137, okay. You have only this much of limited space. और हर एक फ्रीक्वेंसी की एक विड्थ है, तो थोड़ी देर बाद जाके ही मैं दूसरी और रख पाऊंगा, फिर थोड़ी देर और जाके ही मैं दूसरी रख पाऊंगा, फिर थोड़ी देर और जाके ही मैं दूसरी फ्रीक्वेंसी एस्टैब्लिश कर पाऊंगा. My government will not be able to sell more number of frequencies. Every frequency is sold. You had 5G spectrums, right? Auctions, right? Every frequency is sold in crores. Now government wants to sell more, na? From within the same amount of frequency range, if I want to sell more number of frequencies, हर एक frequency की width को मैं छोटा करके ज़्यादा number of frequencies बेचूंगा. यही मैंने किया है. क्या हो गया? I have more number of discrete frequencies available. So what do we do? We can reduce the bandwidth with the help of technological advancements, with the help of better and better equipment. What were we able to do? We were able to separate out the sidebands. हम लोग क्या करते थे? हमारा जो रेडियो था, जो ये सब कुछ चीजें मॉड्यूलेट करके हमको सिग्नल देता था, we were used to have that kind of a radio which could eliminate the lower sideband and it could reduce the bandwidth to half. So now I can have twice the number of frequencies, more number of channels available, more number of frequencies available, which I can sell. Understand? So this type of a transmission is called a single sideband transmission, where I transmit both the sidebands. It is called a double sideband transmission. Going back to your notes, long range communications, they are single sideband transmissions. VHF comms, these are double sideband transmissions. Now are you able to connect it? Told you you will understand this in the next chapter. The next topic is emission designators, which I will be doing next time. That is all for today. Any doubts? Any doubts? Shriram, Ankit, Ujjwal, Akash, Khushi, Anushka, Harsh, Janvi. Any doubts? What I want you to do, Shriram and Janvi, and the RT guys, if you guys are listening to this video, what I want you guys to do is make a briefing of these topics. explain this as a speech. Ujjwal, same goes for you. Speech to the examiner. Prepare a briefing. Teach it to them in the simplest of ways. Ujjwal, you know the example? Do it. I'll be giving you my briefings myself also, but to develop that skill, do it on your own self. Okay, because you don't need this skill. I'll just give you briefings for the purpose of RTR exam. When you go for an airline interview, you will need to prepare briefings of your own about performance, about ASDA, TORA, whatnot. This is something, a skill which will come in handy. Okay, that is all for today.